free, they have greatest kinetic energy in comparison to solid and liquid. Therefore, they have the highest rate of diffusion in comparison to solid and liquid. Let us discuss the diffusion in case of gaseous state. Diffusion in gas. You can smell the hot sizzling food from a greater distance. It means if your mother is cooking food, then you can smell it at somewhat more distances. Why it is so? This is so because the smell of the food diffuses fastly in gases and reaches to you. To the next one, if we discuss the incision stick, when it is burned in the corner of a room, then you can smell it if you are in the another corner of the room. Why it is so? Because the smell of the incision stick diffuses fastly and reaches to you. To the next one, if we have one more example, that you have a question that the smell of hot sizzling food reaches fastly to you, whereas you can't smell the cool food. Why it is so? Because we know in case of hot sizzling food, the temperature is higher, and when the temperature is higher, then the molecule have higher kinetic energy and it has highest rate of diffusion in comparison to the molecules of solid food that is at lower temperature. It means if the temperature is higher, the rate of diffusion is higher because of greater kinetic energy, and if the temperature is lower, then the kinetic energy is lower and the rate of diffusion is lower. It means the example we have, we can smell the hot sizzling food. We can smell the hot sizzling food at a far distance. To the next, we can smell the incision stick. This is an example of diffusion in case of gaseous state. To the next, the first one, we can smell the hot food from a distance is an example of diffusion in gas, because the smell of the food diffuse in air and reaches to us. To the next one, we can smell the incense stick, that is agarbatti. Incense stick, when it is burned, in a corner of a room, because the smell of incense stick diffuse in air and reaches to us. These are the example of diffusion of gas in gas. Let us discuss the diffusion in case of liquid. Diffusion in case of liquid. If we take a beaker and get some water into it, then after placing a crystal of potassium permanganate, what we do? We will take a beaker having some water into it. We will take a beaker having some water into it. And what we do? And we will take a crystal of potassium permanganate into it. When we placed a crystal of potassium permanganate, which is purple in color, then after some time what we see that this crystal of potassium, the color, began to spread in the solution slowly and slowly, which is not as much faster as in comparison to gaseous state. It means the diffusion in case of liquid is somewhat slower. It means, what we have the example, it means when we place a crystal of potassium permanganate in a beaker of water, we can see the crystal of potassium permanganate slowly and slowly diffuse in the solution, and after a certain time the whole solution turns purple. This is an example of diffusion of solid in liquid, or you can say diffusion in case of liquid. To the next, the same example we have, if we will take a piece of copper sulfate crystals which is blue in color and place in another beaker. After placing it, after certain time, when we observe that slowly and slowly the water in the beaker slowly and slowly turns blue. Why it is so? Because of diffusion. It means what we conclude. First one is that when we place a crystal of potassium permanganate in water, then slowly and slowly the color of water in a beaker turns purple. This shows the diffusion in case of. This shows diffusion in case of. To the next, same example, when we placed a crystal of copper sulfate in water, then slowly and slowly the color of water changes to blue. These are the example of diffusion in case of liquid. It means when we place a crystal of potassium permanganate here, it has in this position it has the higher concentration, and I have stated you that the movement of substances from their higher concentration to lower concentration is known as diffusion. In this beaker, here the concentration of potassium permanganate is higher, and here the concentration of potassium permanganate is lower. Here the concentration of potassium permanganate is lower. It means this crystal of potassium permanganate will move from its higher concentration to lower concentration. To the next, what we see here the rate of diffusion is slow in comparison to gaseous state. It means the third point is that the rate of diffusion is slower in comparison to comparison to what? Gaseous state. To the next, we will discuss the diffusion in case of solid. Diffusion in case of solid. We have various examples. Let us discuss few of them. In your school, when teachers write on the blackboard and it is left for a day, then what happens? When teachers write with the help of chalk on the blackboard, when it is left on the for one day, then what we see? The pieces of the chalk are diffused inside the blackboard. Once more, when your teacher writes with chalk on the blackboard, then and when it is left for one day, not at the same time, when it is left for one day, it is quite difficult to erase it. Why it is so? Because the pieces of the chalk has been diffused inside the blackboard. This is the reason. This is the example of diffusion in case of solid. To the next one. If we place two metal blocks close together and bind them and kept them for a longer duration of time. If we are doing so, then after a longer duration of time, we will see that the one metal diffuses in another metal and the another metal diffuses in one metal. These are the example of diffusion in case of solid. The first one, when you write on the blackboard with chalk and left it for one day, then we observe that it is quite difficult to erase it. Why it is so? Erase it. It is so because the chalk particle diffuses in the blackboard. To the next, this is an example of diffusion in case of solid. To the next, if we bind two metallic blocks for a longer time, then we see that one metal get some content of another metal and another metal get some content of the first metal. As we have seen, why this is so? Because of diffusion of solid in solid. In this case, what we are saying, in order to observe the diffusion in case of solid, we have to cap the metal block for a considerable time. We have to rub the board after 1 day. Why it is so? Because the longer duration is required. Because in case of solid, the diffusion is slowest in comparison to all the 3 states of matter. It means the third one, the diffusion in case of solid is slowest in comparison to liquid and gas. What we conclude? The next one, the rate of diffusion is as, first one is gas, then liquid, and then solid. Why it is so? Because in case of gaseous state, the molecule have the greatest kinetic energy. In case of liquid state, they have somewhat lesser energy in comparison to gas state, and in case of solid state, they have least kinetic energy. Therefore, the rate of diffusion is least or the slowest in case of solid state. Clear?